So here we are going to discuss about software measurements. Measurements in the physical world, and these measurements are categorized into two types: direct measurements, indirect measurements. First, we will know what is direct measurements and what is indirect measurements. Direct measurements, which the lines of code we are writing and what are the requirements we are using for measuring it. This all comes under the direct measurements. Indirect measurements are those, it depends upon the quality of the project, functionality of the project, and the product, entire product building of the product. This entire thing comes under the indirect measurements. So this is direct measurements of the products include, as I said, you lines of code, execution speed, memory size, and everything comes under direct measurements. When it comes for the indirect measurements, it comes under functionality, quality, and what is the complexity, efficiency, reliability, or maintainability of the product, whatever you are building. And size oriented metrics, we have size oriented metrics. This size oriented metrics is derived as what is the quality of the product, what is the size of the software you are building or you are producing. This comes under the size oriented metrics. The calculating the size of that software will be done by size oriented metrics. If the software organization maintains simple records, then that comes under the size oriented measures. And here you can see how a project is listed according to the metrics. First we will have project, then we will have lines of code, then what is the effort we are taking for it, what is the price, and what is the documentation you are preparing, and what are the errors, defects, and how many people are involved in building that product. This is the table of list where the project is built according to this table of risks. We will measure the quality of the project we are finally building. So this is the example you can see here. You can see alpha, beta, gamma. You can see lines of code of alpha and effort taken for alpha and what is the price of alpha and the documentation you have created for alpha and what are the errors of alpha and defects you have found here and how many people are involved in building this product. So here now we will discuss about set of simple size oriented metrics. So how you are calculating size oriented metrics. So here the whatever the data contained table, we will have set of size oriented metrics which are developed, and each project will have errors per lines of code, means how many lines of code you are taking that, and the errors for that particular lines of code, the defects you are finding in that lines of code, and what is the cost taken for that lines of code, and also the pages. As I said, we have seen the PP documentation, pages of documentation per KLOC, means lines of code. This is here. You can see here errors and PP documentation. What is the lines of code involved and what is the price of it, and next for each project. Then other metrics we will see errors per person month, lines of code per person and month, and the price taken per page, each page documentation. This way we will measure the size oriented metrics. And next we will discuss about the function oriented metrics. Size oriented metrics comes under the what is the size of the software you are building will be measured using size oriented metrics. When it comes to functional oriented metrics, function oriented metrics, we will use the functionality delivered by the application. What is the functionality delivered by the application will be seen here in functional oriented metrics. Okay. And first what we will do means we will suggest a measure, and that measure is whatever the measure we are suggesting, that is called as function point. We will take that function point and that function point are computed by the table, and here in this table we will have information according to our domain characteristics. Whatever the domain characteristics you are taking, according to that you will have information in this table. Now here you can see how you are measuring here: measurement parameter, count, and simple, average, complex. Okay, it is simple or average or complex. This is the weighing factors you are taking when you are measuring a project, software project. Now what is the measurement parameter here? What are the inputs you are taking? What are the outputs? What are the inquiries you are doing? How many files are involved? What are the external interfaces are taken? This all comes under the measurement parameters. Count, you can see the count may be depends on what are the inputs you are taking, what are the outputs you are taking, and what are the inquiries you are doing. So according to that, you should write the count. And here it may be simple or average or complex. These are the weighing factors which we are depending on the parameters you are taking. So finally, whatever the result you are getting, that will be as the table format. That is about functional oriented metrics. And this here in function oriented metrics, from starting function point we will take, and then we will calculate the domain characteristics whatever you are taking. Now in order to compute this functional point, we will have a general count total formula where you will take the formula 0.65 into 0.01 into sigma of 5. So where count total is the sum of all functional points you are, whatever the entries you are taking, that will be count total sum. As I said you, the entries, it may be inputs, outputs, inquiries, this all comes as the entries you are taking. Now the 5 will is I equal to 1 to 14 is the complexity adjustment values. Whatever the values you are adjusting, as I said you, simple, average, complex, these values will be response on the based on the responses to the following questions whatever we are taking. So in this way we will calculate the functional point count total into 0.6 plus 0.01 into sigma of 5. Now here how, what are the questions generally we will they will be arise when you are calculating the functional point. So these are the following questions which will arise when you are taking the functional point. First, does the system require reliable backup and recovery? Our data communications are required? Are the distributed processing functions? Is performance is critical? You should check it whether the performance is critical or not. Whether the system is running existing or heavily utilized operational environment. Whether online data entry is taken, input transaction will be taken, master files are updated, or input output files, inquiry components. These are the various questions which will be arise when you are questioning for sigma of 5. Now function point metrics. So we will discuss about function point metrics. Once you have calculated the function point, whatever the function point you are taking, and this whatever the function points you are taking, they are used in the manner of lines of code as a way normalize the measures for software productivity, quality, and other attributes. So this function point will be for errors per function point. For each function point, what are the errors? What are the defects for each function point? What is the price taken for each function point? What is the page of documentation you are using for each function point? And what is the cost per person or month will be taken, will be given in the form of function point metrics. So next comes object oriented metrics. So what is present in object oriented metrics? Number of scenario scripts, what are the scripts you are taking, test cases you are taking, what are the key classes you are using, number of support classes, what are the other classes you are implementing, and number of subsystems, means what are the other systems admin classes you are using, average number of support classes per C class, means estimation may be simplified in this object oriented metrics. So next comes web engineering project metrics. Here you will see what are the number of static pages you are taking, dynamic pages, internal page link you are using, persistent data objects, external system interface you are using, what are the content objects, and number of dynamic content objects you are using, executable function points. And here this will be taken as customized index C equal to NDP, NDP plus NSP, NDP plus NSP, dynamic pages plus static web pages. So NDP is number of dynamic web pages, NSP is number of static web. C will be the average from 0 to 1 to increase the customized technical issue. Now, so as you know, till now we have discussed about the size oriented metrics, function oriented metrics, object oriented metrics, and web engineering metrics. So, and metrics, now we will discuss the metrics for software quality. So software engineers must apply effective methods using different tools in order to increase the quality of a product. So a good software engineer must measure if the quality, high quality is to be released. Whatever the product you are building, that product should be of the high quality. So which will be give name to that product, and this credit will goes to the software engineer who is building to the product. So here you can see the quality of the system or application will be depend on the requirements, whatever the requirement. If when you are taking a problem, the requirements you are defining for that problem, and what is the design models you are taking for that solution, and how the code has been taken, or how the code has been written to that problem, and the test you have taken to uncover the errors. This all will, if this all are very good quality, then the product, whatever the software product you are building, that will be of an excellent quality or high quality product. Okay. So a good as I said you, a good software, who is a good software engineer? Who can measure all these accessors, and you can analyze it, design the models, you can code perfectly, and you can test perfectly. Then finally, whatever the software is finally built, it is engineered properly. So this entire thing will be uh, measured, and based on this measurement, you can say the person as a good software engineer who is building the product. Now, factors that affect the quality. So you can see we have following factors, three distinct points which will affect the quality of the product. First one, product operation, product revision, product transition. Okay, product operation means what is the operation of the product, what is way of quality, functionality, how it is working, this how to what extent it is used to satisfy the needs of the customers. This all comes under the product operation. Product revision. So after building of the product, you will go for the revision of the product, and you will revise it. You will check entire product, and that comes under the product revision. Transition. If you got any changes in that product, then how the transition is done to that product. This will comes under the product transition. These 3 points will depend upon the uh, what is the effect it will be on the quality. So first we will discuss about this thing. Now, how you are measuring the quality? The quality is measured. So here, although there are many measurements for the software quality, I can say correctness, maintainability, integrity, usability. User indicates for the project team. So what is the correctness you are taking? What is the maintainability you are giving to the product? How the integrity is going on, and what is the usability of the product? This all comes under the measuring quality. In this year, we will discuss about first correctness. Okay, means when you are building a software, the performance of the software. So if the performance of the software, function of the software is done properly, then that project is of good. So this comes under the correctness. So degree of the correctness, and the most common measurements of the correctness is defects per lines of code. So what are the defects you are finding for the lines of code? This all comes under the correctness. So next, maintainability. So is the ease of the programming, which a program can be corrected if an error is uncovered. So here you will see whenever you are building a project, if you have find any problem, if the error is easily corrected or easily solved, if and also if you want to adopt any changes according to latest trend, you can easily do the changes to that product, and that changes can be done easily, and this entire thing will be maintained by that team. So this process is comes under the maintainability. So if the customer wants immediate changes, the immediate changes can be done easily to the software. You should be aware, or you should aware of that thing, that you can easily correct the software project, whatever you have done or whatever the product you have done. So next, here a simple metric means mean time to change. The time means whatever, if you are analyzing, if you are changing any request, if you want to do any modification, or if you want to test it, or if you want to implement a new change it, this all comes under the mean time to change. This is simple metric which we are using to do all these things. Now next comes integrity. Integrity means ability to withstand attacks. If you are getting any attacks, security attacks, you should be ready to withstand it. You should be ready to solve it. So attacks on all components can be classified as three in the software. First one, programs, data, and documents. So it attacks can be on programs, attack can be on the data, or attacks can be on the document. So the metric integrity of a system is defined as integrity is equal to sigma of 1 minus threat, 1 minus security. So threat means the probability of an attack which is given in a time. Now security means the probability of an attack, that specified type, we will have some type of attack which will be repelled. So this is about threat, this is about security. Now you have other one, that is usability. So effort required to learn, operate, prepare, input, and interrupt the output of a program. So you should learn, operate, and prepare the input of a program, and you should interrupt the output of the program in this usability. The metrics for usability are you should have intellectual skill and physical skill to learn the system, how the system is working, and what is the time you are taking in order to bring a efficient system to the use. This all comes under the usability. Now, next comes defect removal efficiency. Defect removal efficiency is a measure which is used for filtering the ability of quality assurance. Whatever the quality assurance you are giving, in order to filter that, we will use defect removal efficiency. So now control activities also will be used throughout the framework in order to use defect removal efficiency. So defect removal efficiency is calculated as E by E plus D. Okay, E means error. So where E is number of errors found when you are delivering a product to the end user. D means defects found after delivery. After delivery, whatever the defects found are there, and what are the errors found will be. So by calculating this E by E plus D, which will give defect removal efficiency of your software project. Now, next we will discuss about risk management. So here comes risk management. So what is a risk? So first, risk concerns with whatever the happenings which you are done in the future. When the product is given to the customer, what is the problems you are facing, whatever the happenings which are occurring, that comes under the risk. And the risk involves changes. You should do the changes. And also it involves the choices. If you want to change the choice, then it also involves a risk. First, we can see the introduction. What is risk analysis and management? We will see about it. So risk analysis and management, these are the steps in order to understand and manage the uncertainty which is happening in your software product. So the steps involved will be identify it, access it, and estimate its impact, how the impact of the risks is there, and establish a plan in order to solve the risk. So first you should recognize what is the wrong going on, and that recognition of the wrong in the steps will be called as risk identification. So next, you should understand the risk. You should take proactive measures in order to sort the risks, and this managing thing becomes key element of a good project management. So types of risk, we have two types of risk: and reactive risk and proactive risk. So what is reactive risk? So what is proactive risk? We will discuss about it. So reactive strategy monitors the project for likely risks. So resources are set to deal with them. You can deal with them. They should become actual problems. Whatever the problems which you are facing, actually it may occur when you are building a software. And more commonly, software team does nothing about risk until something goes wrong. If something go wrong, then the team will be sit on it and they will sort out it. So then the team files into the action, attempt to correct it rapidly, and this is called as firefighting mode, where you are immediately correcting a risk which has been occurred. So when this fails, crisis management bit occurs, takes over, and the project will be in real danger. Now, a proactive strategy means long before technical work is initiated. So before technical work is initiated, we will find the risk that comes under the proactive strategy. Potential risks are identified, their problem and impact are accessed, and they are ranked by importance. So when you are taking the risk, risks are be ranked by the importance. First, you will give a rank, and according to the ranks, you will sort out the risk. So then the software team after giving the rank, they will establish a plan to manage the risk. Then afterwards, they will primarily objective the avoid risk, but because not all the risks can be avoided, then team works to develop a plan, and they will enable and they will respond according to it, and they will do it according to the effective manner. So what are the software risks? So software a risk involves two characteristics. And first one is uncertainty, and next one is loss. In uncertainty, the risk may not or may not happen. Means that is there is no 100% probability of the risk will be placed. Loss. So in loss, the risk become a reality. Unwanted consequences or losses will occur. So when risks are analyzed, it is important to quantify the level of uncertainty and the degree of the loss associated with each risk. So you should analyze it, you should quantify it, and you should see what is the uncertainty of the risk. And after finding the uncertainty, you should see what is the loss you will be associated with that particular risk. Now, you have different categories of risk here. First one is project risk, technical risk, and business risk. Okay. Another general categorization of the risk is known risk, predictable risk, unpredictable risk. So project risks are the risks which will be coming when we are doing the project, and technical risk, what are the technical issues? This comes under the technical risk, and business risk, which comes under the for the management or in cost price. This all comes under the business risk. We will discuss about it now. Before that, just we will discuss about this known risk, predictable risk, unpredictable risk also. Known risk means you will know this risk will be occur when you are doing the project. Okay. Predictable means this the risks which you think that it may occur, it may occur. Unpredictable means the risk which you won't even think that it may occur, but that risk can be found in a project. That comes under the unpredictable risk. Now, first we will discuss about the project risk. So project risk, what it will threaten the project plan. So here, this if project risk become real, is it likely the project schedule will be shift, the cost will be increased. So project risks are, as I said, you budget problems, schedule slippage, personal resource problems, customer requirements problems. Budget problems means you will estimate a project to complete a project, but the time, the budget taken the project may increase within the time. So this comes under the budgetary problem. Schedule. You may think that I will complete the project within 6 months of the span of time, but due to some problems, you may increase the time to 2, 3, 4 months extra, or you it may take more than 3 months. It comes under the schedule slippage. Means the given within the given schedule you cannot complete the project. Next, personal. Personal means the staff required for the project may be less, or the organization cannot afford more staff, or this all comes under the personal problem of the organization, and this comes under as personal. Resource problems. The resource there is no sufficient resource for the project you are doing. Then this all things comes under the resource problem. Customer requirements problems. When you are taking the requirements, if you are missing any requirements which the customer wants, then this may be dissatisfied to the customer. So these types of problems comes under the customer requirement problems, and this all comes under project risk. Now, next we will discuss about the technical risk. Technical risk is that it will threaten the quality, timelines of the software you are producing. So what is the quality of the software, timelines, what is the timeline given to the software will be used in this technical risk. So if technical risk become reality, implementation may become difficult. As you know, if quality and timelines is not good, then the implementation of the project will be under risk. So technical risk can be identified in design, implementation, interface, verification, maintenance phases. So in addition, we will have specification ambiguity and leading edge technology are also under risk factors. So here technical risks occur because the problem is harder to solve. So we thought it would be, means when you are taking a problem, if it is harder to solve more than we are thinking, then it comes under the technical risk. So next we will discuss about the business risk. Business risk means threaten the availability of the software to be built. Whatever the availability of the software you're taking, it will be threatened. So here business risk will be given in the type of priorities. So we have top 5 business risks. Building an excellent product or the system that no one really wants. So you are building a product or building a system, but that doesn't have any market. So when you are completing the building, it doesn't have any market, which may be a big risk for the business. Next, you are building a product which doesn't fits to your society or to your business strategy or to your company. Now, you are building a product that the sales force does not understand how to sell it. So a product is building, but you cannot understand how to sell it. Next, and losing budget or personal commitment means budget risk. If you are thinking that I can complete within 1 crore, but it is unable to complete within that particular budget, and the budget may increase. So this may also comes under the business risk. Now, risk identification. As I said, you have different risks: project risk, technical risk, business risk. But how you are identifying this risk? So this will be done in the risk identification. Risk identification means is a systematic attempt to specify the threats to the project plan. When you are giving a project plan, then here you will have some attempt to specify the threats. You have some attempts, so that threats will be getting to that plan, and this thing you should be ready to identify whatever the threats you can specify. So this will comes under risk identification. And here, by identification known and predictable risk, the project manager takes a first step toward avoiding them when possible and controlling them when necessary. As I said you, we have three types of risk: known, unknown, and predictable. So here, known risks and predictable risk will be known to the project manager, so he can take a forward step and he will try to solve it whenever it is required. And here, so there are two distinct types of risk for each and every category: generic risk, product specific risk. So generic risk are a potential threat to every project work. So every project work will have that generic risk, normal threats. Product specific risk can be specified only by those clear understanding of the technology of the people. The people who know perfect technology, they can only specify that risk, and the environment that is specified to the project of a hand, or the environment whatever you are taking, they can only specify the product specific risk. Now, risk identification procedure. How you are identifying the risk? The procedure will, we should see the procedure. So one method to identify the risk is create a risk item checklist. So you will create a checklist, and that checklist consists risk items. So that checklist can be used for risk identification and focus on the subset of what are the predictable risks you are getting. So that types of risks are project size, business impact, customer characteristics, process identification, development, environment, technology to build, staff size, experience. This all comes under the predictable risk. Questions relevant to each of the topics can be answered for each project work, and these answers allow the planner to estimate the impact of the risk. What is the impact of the risk? So finally, set of risk components and the drivers are listed within this probability of occurrence. So this comes under the procedure to identify the risk. Now, accessing overall project risk. So how you are accessing overall project risk? Here you have some questions. So these questions are used in order to access the overall project risk. How have top software and customer managers formally committed to support the project? Are end users enthusiastically committed to the project? Are system and product to be built? Are requirements fully understood or not? Have customers involved fully or identified? Do end users have realistic expectations? Is project stable? Does the software engineering team has the right mix of skills? Our project is stable, requirements stable, so project team has experience. Is number of people taken in the project team are advocate to do the job? Or do all the customers use it, agree importance of the project and requirements to be built? So here these are the accessing problem, and here you are impact categories, how the risk is impacted. So you can see the table. Here the table is divided into two things: components and categories. In the components, you can see components, performance, support, cost, and schedule. Next category, you can see catastrophic, critical, marginal, and negligible. So here performance, support, this all comes again divided into parts. In catastrophic, you can see failure to the meet requirements, failure results. This all comes under this significant degradation. So this is the table which will see the impact categories of the project. You can see critical, you can see failure to the meet requirements, degrade system performance, where the mission successful, and same reduction technical performance, minor delays in software modification. Failure results, you can see delays and increased cost of the expected. Next, some of the shortage of financial resources, possible slippage in IOC. Marginal, you can see failure to meet the requirements, would stop, result in the degradation of the secondary thing, cost, impacts, recoverable. Minimum to small reduction, technical, responsible software, sufficient financial resources, and realistic. Next, negligible, you can see failure to meet the requirements, create inconvenience, no operational, and error results in minor cost, no reduction in technical performance, easily supportable, and possible budget is taken, and easily achievable IOC. So this is the impact categories which you are taking. Now, till here we have discussed about the what are the types of risk, what are the software risks, types of risk, software risk we are using, and what are the various types of categories of risks, and we have discussed about the categories of risk. And next we have discussed what is risk identification, how you are identifying the risk, and what are the two different types of risk, generic and product specific risk, and what is the procedure you are using in order to identify the risk, and what is the accessing of overall project risk, and what are the impact categories we have for this risk.